Hello, welcome back to Mrs. Torres' YouTube channel. Today, we are going to continue talking about right triangles. Well, we're going to talk about two special cases of right triangles. Because they're special cases, instead of using the Pythagorean theorem, there's kind of shortcuts that we can use to find the missing sides. The first special right triangle that we're going to talk about is called a 45, 45, 90 triangle. That is a triangle with angle measures 45, 45, and 90. Hence the name, right? So I'm going to kind of walk us through discovering what this shortcut is. Here we have a 45, 45, 90 triangle. Our sides are 1. So let's use the Pythagorean theorem to see if we can find out what C is. That would look like this. 1 squared plus 1 squared equals C squared. 1 squared is 1, right? So 1 plus 1 gives us 2. And then, of course, to get C by itself, we've got to take the square root of both sides. So C equals the square root of 2. We can just leave this as exact. There's no need to get a decimal here. All right, let's look at the next one. Now, the next one, it doesn't have 45-degree angles here, but it's telling us that these are equal, right? So 100 minus 90 leaves us with 90 degrees for these two angles. Split it in half, you get 45 and 45. And of course, in every 45, 45, 90 triangle, our legs are congruent, right? Because they're across from or opposite of our congruent angles. So that would look like this if we were looking for C. 2 squared plus 2 squared equals C squared. 2 squared is 4, so 4 plus 4 gives us 8. So C equals the square root of 8. I want simplest radical form, so we have to simplify this. 2 and 4, 2 and 2. So C in this case would be 2 root 2. So now I want you to think about what's the relation between leg and hypotenuse? Well, here we have 1, and then we have 1 root 2. There's really a 1 here that we don't write, right? Here we have 2 and 2 root 2. So the rule is, in a 45, 45, 90 triangle, the shortcut or rule is the hypotenuse is equal to the leg times the square root of 2. So if we say our legs are x, remember they have to be congruent. So if they're any number, whatever x is, our hypotenuse is going to be x root 2. X root 2. So let's look at some examples to really see what I mean here. I want to look at number 3 first. Number 3 is kind of the most basic one. So we've got a 45, 45, 90 triangle. We're looking for x and y. The hypotenuse is 4 root 2. Well, we know the hypotenuse is the leg times square root of 2. So 4 root 2 means the legs are just 4. Because if the legs are 4, hypotenuse is 4 root 2. Easy. All right, let's look at 1. So number 1, we were given the leg. So our leg is 2 root 2, which means our other leg is 2 root 2. Now we need to find the hypotenuse. The hypotenuse in a 45, 45, 90 triangle is equal to the leg times the square root of 2. So our leg is 2 root 2 times the square root of 2. These square roots, I know sometimes can look really intimidating, but it's just a number. The square root of 2 is just a number. It is an irrational number, so that means it's a decimal that goes on forever and doesn't repeat. But it's, at the end of the day, just a number. So the square root of 2 times the square root of 2 gives us 2. So this is 2 times 2, which gives us 4. So that means in this case, the hypotenuse is 4. All right, let's look at number 2 now. So number 2 is a little different. This time we were given the hypotenuse, but unlike here where we can just grab out whatever that leg is, it's just an integer. So think about the rule or the shortcut. It says the hypotenuse is equal to the leg times the square root of 2. And then let's plug in what we know. So the hypotenuse length is 8 equals the leg. We can use either one of these variables because they're going to be equal, right? So I'm just going to use m times the square root of 2. Now, the square root of 2 again is just a number. So whatever we would normally do to solve an equation, we can do here. So we have we have m times a number. So to get m by itself, we've got to divide by that number, right? So those cancel. We're left with m equals 8 over square root of 2. But we're not done. We can never have a square root in the denominator, so we need to rationalize. So that'll give us 8 root 2. Don't forget, square root of 2 times the square root of 2 just leaves us with 2. And our last step, think of this as a fraction, right? 8 over 2, we can simplify to 4 root 2. So that means here our legs are both 4 root 2. And number 4 on this page is actually the same exact one as number 1, so we're going to skip that one. All right, go ahead and flip over your notes packet to page 8. All right, so page 8, we have another type of special right triangle. This time it's called a 30, 60, 90 triangle, which you guessed it is a right triangle with measures 30 degrees, 60 degrees, 90 degrees. In a 30, 60, 90 triangle, we of course still have the hypotenuse, right? That's always across from our right angle. And then we have our two legs. Unlike 45, 45, 90, where the legs are equal, we have a shorter leg and a longer leg. So this is our short leg, and this is our long leg. Our short leg is always going to be across from our 30-degree angle, right? Remember, opposite angles and sides correspond. So let's use the Pythagorean theorem to figure out what our long leg is for both of these. All right, so here we've got 1 squared plus, I'm just going to call it b squared equals 2 squared, because of course 2 is our hypotenuse. So that's going to give me 1 plus b squared equals 4. If we would subtract 1 from both sides, we'd get b squared equals 3. And our last step, got to take the square root. So b equals the square root of 3. So we're thinking, okay, it's probably something with the square root of 3, right? Last time we were using square root of 2. This time we got the square root of 3. But let's look at our other triangle to see. All right, so we've got 4 squared plus b squared equals 8 squared. 4 squared is going to give us 16 plus b squared equals 84. Subtract 16 from both sides, we're going to get b equals the square root of 48. Now I want it in simplest radical form, so let's go ahead and simplify. That would give us 4 and 12, 2 and 2, 3 and 4, which is 2 and 2. So we have 2 pairs of 2s, so that gives us a 4 on the outside. And what's left without a pair? That's just 3. So, I will give you one hint here. In a 30, 60, 90 triangle, everything is based on the short leg. So how is the short leg related to the hypotenuse? How do we get from 1 to 2? How do we get from 4 to 8? Well, 1 times 2 gives me 2. 4 times 2 gives me 8. So that means the short leg times 2 will give me the hypotenuse. So the hypotenuse is equal to the short leg times 2. We could also think about it the other way. The short leg is half the hypotenuse. Sometimes it might be beneficial to think about it that way as well. And then let's look at our long leg. So again, it's based on the short leg. How do we get from here to here? How do we get from here to here? Well, remember there's a 1 here. So it looks like the long leg is just the short leg times the square root of 3. So short leg times square root of 3. Short leg times the square root of 3. So long leg is the short leg times the square root of 3. So if we use variables here, I'm going to call x our short side, because that's what all the other sides are based off of. So that means the hypotenuse is going to be 2 times x, right? And the long leg is x times the square root of 3. So that's our shortcut that we can use instead of the Pythagorean theorem. All right, let's look at number 1. So when we're given the short leg, that kind of makes our job easier because that's what everything's based off of. So if my short leg is 7, my hypotenuse is 2 times that. So that's going to be 14. If my short leg is 7, my long leg is just 7 times the square root of 3. And that's it. When our short leg is an integer, it makes our job very easy. Let's look at number 3 first, and then we'll come back to number 2. So now we're given the hypotenuse, and we need to find the short leg and the long leg. Well, we know if we double the short leg, we get the hypotenuse. So that means if we have the hypotenuse, we can cut that in half. So 5 over 2. You can leave that as an improper fraction. Don't get a decimal. Just leave it as 5 over 2. And then we need the long leg. So the long leg is the short leg times the square root of 3. And then we can actually write that as 5 root 3 over 2. Because this is really 3 over 1, right? We don't need that 1 in the denominator. So x is this, and y is 5 halves. All right, let's look at number 2 now. So number 2, our given side is across from our 60-degree angle, so we know this is our long leg. So n is our short leg, and m is our hypotenuse. We always want to find the short leg if we don't have it, because that's what everything is based off of. So let's think about what we know about the relationship between long leg and short leg. So we know, I'm just going to say LL for long leg, is equal to the short leg times the square root of 3. And then let's plug in what we know. We know the long leg is 9. The short leg is variable n, and then times root 3. It's very similar to the one that we did with 45, 45, 90, except this time we're going to divide by the square root of 3. Remember, the square root of 3 is just a number. Anything that you would normally do with a number, you can do with the square root of 3. So those cancel. We get n equals 9 over root 3. But, of course, we can't have a square root in the denominator, so multiply by root 3 over root 3. So in the numerator, we'll get 9 root 3 over 3. Those we can divide both by 3, so we get 3 root 3. So there's our short side. And then our hypotenuse is going to be 2 times our short leg, which is 3 root 3. All we can do there is multiply, so we would get 6 root 3. We can't multiply anything under the square root because that's the only square root we have. We can just multiply the numbers on the outside. All right, I know this is a lengthy lesson, but here's our last example. All right, so we got 30, 60, 90. This is our hypotenuse. So our hypotenuse, or our short leg, I should say, short leg is equal to half the hypotenuse, right? So we're trying to get that short leg. The short leg, we can plug in b equals 1/2 times, remember when you have a fraction then of, that means times, so 1/2 of 4 root 3 over 3. We've got to remember how to multiply fractions. That's just straight across. So 1 times 4 root 3 gives me 4 root 3. 2 times 3 gives me 6. And then we can simplify 4 over 6 to 2 over 3. So 2 root 3 over 6. So that is my short side. Short leg, I should say. Now that we have the short leg, or I should say the long leg, is equal to the short leg times the square root of 3. So short leg is 2 root 3 over 3. We just found that. Times the square root of 3. We can really think of that as the square root of 3 over 1, right? Every number is over 1. We just don't always write it. And then we just multiply fractions. 2 root 3 times root 3. Well, let's think about it. These are just going to give me 3 times 2 is 6 over 3 times 1 gives me 3. So after all that, our long side is 2. All right. See you next time.